leading strand is 3' to 5', and the lagging strand is 5' to 3' whenever replication begins. First, gyrase comes and relieves supercoiling ahead of replication, and it helps the helicase split the DNA. Then the helicase comes, splits DNA, and breaks the hydrogen bonds. Once it does this, the single-strand binding proteins, which are referred to in the video by SSBP, are going to keep the strands separate, stabilize them, and prevent hairpins, which is whenever the single strand folds in on itself. We're going to start with the lagging strand because it's the most complicated, but I wanted to point out that at the origin of replication, the leading strand does get one RNA primase that adds an RNA primer, and then it continues from there, but we'll come back to that. First, whenever the RNA primase adds the primers on to it, it does it from 3' to 5'. It also creates phosphodiester bonds to join the nucleotides whenever DNA polymerase III comes to add the complementary nucleotides. There is a problem in this video because I accidentally added the magnets on from 5' to 3', and instead of reshooting it, I just thought I'd let you know that I accidentally messed that up. So hope you can forgive me. But then the DNA polymerase comes in, and the polymerase III comes in and adds nucleotides from the 3' to 5' end, not the other way around, which I accidentally put in the video. Once the DNA polymerase comes in and goes all the way to the next primer and stops, the DNA polymerase I comes in and replaces the RNA primer with nucleotides. This happens all the way down, and the piece that is the broken nucleotides on both sides is called an Okazaki fragment, and that is how the lagging strand replicates. Then, whenever the DNA polymerase is done, next comes ligase, and ligase seals the nicks that is left between the breaks, and that is how the lagging strand goes. Now, the leading strand is much simpler, and what it does is it just DNA polymerase III starts at that RNA primase and RNA primer and goes all the way down until the end when it's done. This allows continuous replication, which is why it's called the leading strand. And after that, then the DNA polymerase I comes, replaces the primer with nucleotides, and then it's just breaks